Right, the lab that we're going to be doing is how can we determine the molarity of bleach in commercial bleach. So bleach or sodium hypochlorite. So we want to determine the amount of sodium hypochlorite in our solution. Generally, if you want to do some kind of analytical test like that, at least in general chemistry, you'll probably be using titration. So you might consider, perhaps we can add some acid to this base, hypochlorite, to form hypochloric acid. And we can determine via acid-base titration. However, you cannot do this because if you form this compound, you're also going to be at the same time then forming chlorine gas, which is toxic. So instead of titrating this base with an acid, we're going to be titrating this oxidizing agent with a reducing agent. And this should be much, much safer for us. And so we're going to be preparing a solution of sodium hypochlorite first. So we're going to take commercial bleach solution, which is bought in a grocery store, and we're going to take that and dilute it a little bit. So we'll take 5 milliliters of it using a volumetric pipette, which is very, very precise. Hence, we get these extra 2 digits after the decimal. So we'll take 5 mils of that commercial bleach and put it into a volumetric flask and dilute that until it's at 100 milliliters. So this we'll call our diluted bleach solution. We're then going to take that diluted bleach solution, add it to an Erlenmeyer flask, and then add 2 grams of potassium iodide. And then in the fume hood, we're going to use or add 2 milliliters of 3 molar hydrochloric acid. We must do this in the fume hood because it does release a little bit of chlorine at that time. Fortunately, the reaction with the acid should occur quickly, though. You see, under the presence of acid, that hypochlorite will react with the iodide of the potassium iodide, and so that it will, it will oxidize the iodide into iodine, and the hypochlorite will be reduced into chloride. Now, we don't have the ability to use a traditional indicator because we're not using acid-base titration here. And so instead of using traditional indicator, we're going to use this fortunate fact that iodine, which is highly colored but insoluble in water, will react with some of the excess iodide and form iodate. And actually, well, I3 minus. Now, this I3 minus, this will then be titrated with our thiosulfate solution. Now, I3 minus is a highly colored solution. It's somewhat dark, and so as we add thiosulfate to that I3 minus, the color is going to be reduced as we go ahead and reduce the I3 minus into I minus. So we'll see that the color is changing. However, in order to have some more precision in that color change, we're going to use a starch solution near the end of our titration. So near the end of the titration, we're going to add a dropper full of starch solution. So that starch solution, even when there's a very small amount of I3 minus, is very, very dark. And as soon as that I3 minus is eliminated, that color should dissipate. In this titration, then, we'll stop when the color has dissipated in that starch. And so we'll know then how many liters of this certain known molarity standard thiosulfate solution are required to titrate this hypochlorite solution. And so knowing then the number of liters and the molarity of that thiosulfate solution, we'll know the moles of thiosulfate reacted in order to titrate that hypochlorite. Now, ultimately, right now, all you know is the relationship between the moles of thiosulfate and I3 minus. You see it's a 2-to-1 ratio. But when you know how many moles of I3 minus have reacted, you'll know how many moles of I2 had been used to build that, and therefore you'll know how many moles of hypochlorite were used to create those I2s. And so you'll know ultimately the number of moles of hypochlorite in your dilute bleach solution. And knowing the moles and the volume of your dilute bleach solution, you'll know the molarity of your dilute bleach solution. However, this is not the same as the molarity of the commercial bleach solution because you did dilute it 4 times. You took 25 mils of the dilute bleach solution, which had been formed from adding only 5 mils of commercial bleach solution to 95 milliliters of distilled water. So you'll need to convert from the molarity of the dilute to the molarity of the commercial bleach solution. And then with your molarity, you may be able to calculate the percent mass, the composition of bleach in that solution. And so then you can find the percent error as well. So this is kind of like our titration that we've done before, except a lot more complicated and a little bit different because it's a redox titration, not an acid-base titration. Thanks for watching, guys.